Hi. Okay, so this is designing for mobile VR, and it's 1 minute past our start time, and I got a lot of slides and 25 minutes to tell you all this stuff, so I'm going to get started. My name is Chris Pruett. I am the co-founder of a mobile game studio called Invader. I'm also an employee at Oculus. Today, I am going to be telling you about a game that we built at Invader called Dead Secret, which is a murder mystery game that originally started out for tablets and phones and is now running on mobile VR platforms. Although I am an employee at Oculus, this is not a talk about any particular hardware or VR platform. This is a talk about specific design changes that we made in order to transition our game from a traditional sort of tablet platform to a mobile VR platform. So before we get started, I want to show you a trailer for Dead Secret that I hope will give you an idea of what the game's about. Okay, so that's Dead Secret. The story of this game is that we started it in 2013, and the idea was we were going to build it with a small team in a short amount of time. It was going to be a pretty simple but very beautiful sort of 3D Nancy Drew via David Lynch kind of game. What actually happened is that we worked on it for a little while. We put it on the shelf. We went and shipped another game called Wind Up Night 2 for a while. And then we came back to it last summer. And I managed to get my hands on an early Gear VR dev kit from Oculus and took it home and brought the game up in VR. And it's kind of an amazing experience. I don't know if anybody in this room has actually done the work to bring their existing game to VR, but the first time you put this headset on and you're no longer looking at a room that you've seen or a space that you've seen on the screen anymore. You're actually in the space. That was an amazing experience, and I only needed like that first 30 seconds to convince me that this was something we should do with this game. There was a big problem, though, and the problem was that you couldn't play the game anymore. Now you could look around, and the environments are really nice, and I'm like, wow, it's 3D. I'm looking at the environments. But you couldn't do anything. And the reason you couldn't do anything is that you no longer had a tablet or a touchscreen to manipulate. I should say that at this point, the game was basically playable from beginning to end, although we still had a lot of work to do. So we went to work rebuilding the UI and interactions and the game design for VR. And we ended up rewriting all of our user interaction code, all of our UI code. Whole bunch of stuff had to be invented from scratch. And then we changed the level design, and we changed the puzzles, and we changed the story. The side effects of this change were pretty massive for our game. But a bunch of months later, it's running really awesome on mobile VR platforms, and it's a better game even on traditional platforms. So what I want to talk about today is specifically our experience of moving from sort of one platform to the other and why our game got better in the process. So the idea of mobile VR is not particularly new. This is a Saturn scope. Mine was built in 1895, and the way that it works is you have these little cards, and they have a stereoscopic photo on them, and you sort of put them in this little thing and adjust the focus until you see a stereo image. And it's basically like a super old-school ViewMaster. But the idea that you could have something that you could take with you that had a swappable sort of stereoscopic 3D scene is something that's been around for quite a long time. You know, it's just been only recently that technology has caught up to the idea. The really awesome part about mobile VR is that there aren't any wires, right? Unlike a PC VR platform, you're not tethered to a computer. So you can actually ask the player to spin in 360 degrees and make games that involve spinning in 360 degrees. And that's something that's difficult to do on any other sort of VR platform. There are a bunch of caveats, though. First of all, depending on which mobile VR platform we're talking about, you might expect the player to be holding something to their face. There's no keyboard or mouse. You might or may not have access to a controller. In our case, we could support a Bluetooth controller, and we chose not to because we want our players to not have to lug one more thing around. So we're going from a tablet game that had a bunch of sort of tablet-y interaction verbs like tapping, dragging, zooming, pinch, zoom, shake, all those things. And those are basically all gone now. Now we have tapping. And you know, technically speaking, some of these devices, like the Gear VR, has a little touchpad here, so we could have done dragging or something like that. We decided to massively simplify our interface and make it just a tap. But it turns out you also have one other interface that you don't have on other platforms, which is your head. And your neck is actually a pretty good game controller. So we're doing something that's called a gaze cursor, which is basically a cursor that comes out of your nose like a sight, and there's a cursor on the end of it, and as you move around, it moves with you. And by using that, you can look at something and then tap to select it. So now you can tap to open a door, tap to turn a safe dial, you know, tap to pull out a drawer or something like that. So what's happened here is that the depth of our mechanical interaction got really shallow, right? We had a bunch of, you know, pinching and dragging and pulling and doing stuff on a screen, and all that's become a tap. But with this change, with the gaze cursor and a tap, suddenly the game is playable again. We're no longer just, you know, looking at the environment. Now we can walk around, we can go through the rooms, we can try to solve the puzzles. You can now play the game in VR. And this is like our first stage of work. And then we reach the second stage, which is when we realize that our puzzles don't make sense anymore. And the reason our puzzles don't make any sense is because most of our puzzles were sort of interaction puzzles. They were based on some mechanic. Like, maybe you have to press these two buttons at the same time using two fingers. Well, now that that's gone, you just tap on it and complete the puzzle. It's no longer a puzzle, right? It doesn't really have any reason to exist. So basically, we, you know, reduced our game to this thing. You know, great, it's in 3D. So then became what I'd call the second phase of rework, which is we started to rework the game design to fit VR. And we threw a bunch of puzzles out. The puzzles we could modify to work in VR, we salvaged and you know, changed. Most of them, the general pattern was they went from being a mechanical puzzle to a logic puzzle. So for example, this puzzle box originally only had two buttons, and you had to figure out that you needed to press them both at the same time. Now it's a puzzle about collecting the requisite items to complete the puzzle box and then pushing the buttons in a sequence. And you have to read clues and documents and figure out what that sequence should be. By changing it from a mechanical puzzle to a logical puzzle, we allowed ourselves to keep the puzzle element of this game, even though our mechanical interaction become very simple. We also simplified our locomotion quite a bit, and I want to take a minute just to talk about locomotion because I think it's really important for VR. The way that locomotion works in Dead Secret is you look at where you want to go, and you tap the side of your head, and you walk over there. It's not a first-person shooter control scheme, and that has a lot of implications. I think if we think about locomotion in terms of sort of expressiveness of controls as opposed to complexity or density of the environment, we can pretty easily tell that games that are very expressive in their controls can't have a very dense environment. You know, if you're playing a modern first-person shooter, you know, control scheme looks kind of like this, right? This is a really expressive control scheme. And in fact, the entire game is about navigating space the way you want to with this control scheme. And as a result, you know, you really don't have time nor the inclination to stop and look underneath every pillow or investigate what's in the wastebasket. You're on your way somewhere else. The map is very large. And the granularity of content in, like, say, of a meter for meter space is pretty sparse. We can contrast that with an escape the room game, right? Escape the room is a genre where you're basically fixed in one place. You can rotate in place, and you can look at this one room, but you can't go anywhere. And there's tons of stuff to do in this room, but it's hard to find. So you'd be looking under the pillows, or you've been looking around the back of the desk, or examining things that are in the wastebasket. This is the other end of the spectrum, right? This is no locomotion whatsoever, but extremely high density in the environment. Now, VR, particularly mobile VR, has some strict requirements when it comes to motion sickness. And one of them is that we really don't want to move the camera if we can avoid it. One of the things that makes people sick the most is rotating in place, exactly like you would if you had a right stick rotation on a first-person shooter. So we have a game that we've decided is going to be pretty locomotion simple, and our interactions are generally becoming simpler as we move to VR, and also we know the requirements of VR that we move the camera as little as possible. So the side effect is that the density of our environments has to improve. In order for this to remain an interesting space, we need to take the relatively small number of rooms that we have and just pack them full of stuff. So now you'll be in a room, and there's a lot to do in every room. And that's actually a pretty major design change from what we had before. What's interesting is that when I look at these rooms that we're now building for VR on the screen, a lot of the time they feel cramped or crowded. And as soon as I put the headset on, they feel open and airy. And I couldn't figure out why it felt so different. And it's not just that it's now in stereoscopic 3D and I'm wearing a headset and I can look everywhere and it's great. There's something more to it. And eventually I figured out that it's because we were real sticklers about our scale. Everything in this game is built to proper scale, starting with the foundation for the house, which is based on real architectural plans. And we did that as part of a design goal way back in 2013 when we started this, but it turned out that when we switched to VR, it was a godsend because our spaces feel real. They're properly sized, and your brain knows what that feels like when you put the headset on. We also changed the map progression quite a bit. The progression in Dead Secret is based on this model that I call recursive unlocking, which dates back to Resident Evil and games of those eras. And the idea is that this is a visualization of a speed run through Resident Evil 1 that I made a couple of years ago. The idea is that you start out with a small space with a bunch of locked doors, and as you move through the space, the doors start to unlock. And eventually, the space becomes open and larger and more complex, kind of like a Fibonacci sequence or a shell. And at some point, you actually aren't interested so much in getting to the new space as much as you are finding the fastest path through shortcuts in the space that you've already opened. And I really like this system because it encourages the player to go back and look at things that they've seen before. It encourages them to loop back through the map several times, but it also it allows us to control when the player does that. And because it's very important to limit the amount of camera motion as much as we can, it became doubly important that we control when the player decides to move into new spaces so that we don't have them wandering around a large space sort of aimlessly, possibly making themselves sick while not finding any new game in the process. Also related to the locomotion, our motion between rooms and between nodes is originally based on visible nodes on the ground that you could see. And you'd sort of say, oh, I want to go over there, and you'd click on it, and she'd walk over there. And there's a spline that would take you very nicely, and it was all very cinematic. And when we went to VR, first thing we did was we got rid of the visible nodes. Now you just sort of click in the direction you'd like to go, and off she goes. But the second thing we did is we took all our splines and just straightened them out. Because, again, we don't want any rotation on the camera if we can avoid it. The only rotation we want on the camera is something coming from the player's neck. So we never, ever, ever turn the camera for you. It's up to you to turn the camera, which means you can turn around and walk backwards in this game if you so decide to do so. But it feels better when you're moving forward. The side effect of making these things straight. I should also mention we took out all acceleration on these lines. Originally we had sort of an ease in, ease out, beginning and the end of the spline. All that's gone now. Acceleration, turns out in VR, feels really bad. So now it's linear velocity across the map. And I know there are people in here who are thinking like, linear velocity feels terrible. You can't have a first-person game where the character moves at a constant speed. It feels terrible. But I challenge you to try it in VR. The thing about VR is your expectations are probably wrong. and it feels significantly better this way than it did before. However, the side effect was now you should really be able to go anywhere you want to go, and we still have this sort of point-and-click motion system. So the result was our map design had to really increase the number of places you could stand in the world. So every one of our rooms, in addition to being packed with more content, actually has a lot more places to be. Also, I mentioned earlier that the nice thing about mobile VR is that there are no wires. I'm going to go a step further and say this would be a pretty hard VR game for us to make on a PC. I would love to figure out how to ship this game for PC VR. There's a lot of really cool stuff going on in the PC VR space. But this game is designed around the assumption that you can turn in any direction and start moving in that direction. And if you can't do that because a cable's going to get wrapped around your neck, then I have to figure out something else, some other solution for you to be able to turn. Because the way that's implemented currently, it's as uniquely mobile VR. I want to talk about UI, because UI in VR is super hard. And we spent a ton of time on it. OK, so I mentioned that we have this gaze cursor, right? This is the cursor that comes out of the end of your nose and sticks on stuff. This took us like 5 iterations to get right. It's not a complicated thing. It's just this cursor at the end of your reticle. I mean, it is like a reticle in a shooting game, you think. Turns out making it work properly was pretty hard. Our first implementation was that when you looked at something you could interact with, there'd be like a little pop-up. Like it would come up and say, oh, hey, I'm a door. You can open me. And that sucked. That was really bad because you don't know where you can look at. And you have to sort of look around and try to find the exact point you can look. And you don't have any indication of where exactly you're looking. So maybe you think your focus point is here, but in fact, the ray that's being shot out of your nose is over here. And it sucked. Next, we switched to like a little dot on the screen and some color flashing. So you look at the door, and the door would be like, hey, I'm flashing. That means you can interact with me. That sucked, too. The artists were like, but also, it just didn't tell you what the interaction was going to be. Right? You could do some anonymous interaction. Maybe it's walk over to the door. Maybe it's open the door. Maybe it's comment that the door is too far away and I can't get there. And you don't know what it's going to be until you click. And I don't think that's very good UI. So now what we have is this context-sensitive cursor graphic, which is right here in the picture. You can see it's a little arrow. That means I'm going to go through this door when I click. It could be also walk around to another space or pick up an item or use an item, something like that. This actually works pretty well, and we're very happy with it. The key to making this cursor work, though, is it has to stick to geometry in the world. And this is a really fascinating thing that I did not understand until we put this game in VR. And that was that your eyes are going to focus. I mean, you're looking at a stereoscopic image. And as far as your brain is concerned, you're looking at a real place. So your eyes can focus in on stuff that's out in the foreground or something that's close in the foreground. And your eyes are actually changing their focus depending on what it is and how far away you're looking at. So my initial implementation of this was just to take a quad and literally like hang it in front of the camera and move it around as you looked. And it feels awful because your eyes don't know if you're supposed to be focusing on this thing in the background that you're trying to look at or this thing that's hanging closer in front of you. So the solution is just to take the cursor, project it against the world, and make sure that it sticks to something at the same focus depth that the eye is looking at. And that works really well. OK, so we have a lot of text in Dead Secret. I mean, if you play this kind of game, you're probably familiar with the sort of level of documents and commentary that has to go on in order for these characters to express themselves. And text in VR is pretty challenging. When we had a tablet game, rather, the way that we did text was basically just a little subtitle. Come up at the bottom and say, hello, I'm looking for the killer. And my initial implementation was just take that subtitle and, like the reticle, just hang it in front of the camera and say, OK, done. This is pretty much the worst possible thing that you could do. Because for the same reason, your eyes are now focused on something in the background, whatever it is you've just looked at. And now you've dropped some plane in between what your eyes are focused on and your head that your eyes don't know how to focus on. It actually takes effort to focus your eyes on this little spot. And there was a moment in which I was implementing this, and I was trying to read the text. And I wrote this text. Like, I know what it says. And I could not force my eyes to read it. So the solution is to also stick it to the world. And so now all of our text appears in world, and it's stuck to something close to what you just looked at. And the really cool thing about this is that it could have caused us to come up with a whole art style related to text hanging in space that's worked out really well for us. Other kind of text are like documents that you have to read. And my mantra here is make it something that's real in the world. Put it put it in the world, make it projected in real space. So our document system involves a folio that you have that opens up that has a document that's at an angle that you read. Now, this is actually a lot trickier than it looks, because in order to make this look proper, this folio has to hang a certain distance from your head, so when you rotate it, it doesn't feel like it's stuck to your face. But it also has to render at a resolution that's readable, and the solution is to actually make the folio like super giant. Folio is like half the size of the character. And you can get away with this as long as you hide the background. If there's no size cue for the player to know that what they're looking at is abnormally giant, then they won't notice. Also, reading in VR just is kind of hard, generally. We've tried a lot of different stuff, and I'm sure there are other solutions out there. But at the current, these devices that are available today are the highest resolution commercially available VR devices, and it's still pretty hard to read text if it's any appreciable distance from the camera. So we just started to reduce the amount of text in our game. And actually, this had a really nice side effect of making our story better, because it forced us to edit and become tighter. If you're making like an Iron Man HUD, where it's something that's in the world and it's stuck to your face and it's like a helmet, then you're probably going to be fine. But if you're making games like I was making them, which is basically a 2D plane on top of a 3D surface, and you want to make that into VR, you're going to have some work to do. And we are still working on UI for VR. It has turned out to be one of the most challenging things. This isn't specifically design related, but I'm going to very briefly touch on performance because it's really important. We must maintain 60 frames a second all times on this device. And actually, that's quite challenging, even though we've been shipping high-end 3D games on mobile devices for a long time. But in VR, the requirements are significantly higher because we're rendering the frame twice. So we're actually running at like 120 frames a second. Guess what happens if you don't run at 60 frames a second? It's not good. For us, the solution to performance has been almost entirely about draw call optimization. Draw calls, because we're rendering the entire frame twice, we end up issuing the draw calls twice. That's been the area that we've put the most effort into. And we even went as far as implementing our own occlusion culling visibility system so that we can do highly accurate visibility culling at runtime. We do pull a few tricks like this mirror. If you think about how to render a mirror in VR, it's like the worst possible case, because you render the left eye and the right eye looking at the mirror, and then you have to render left eye, right eye reflection from the mirror, and now you've rendered your scene 4 times for one frame. That sucks. So this mirror, this is one of our few technical tricks. We only actually render each eye at 30 frames a second, and we alternate which one is rendering per frame. And as long as there's no huge amount of motion, it looks great. So here's like the TLDR of this talk. The main things that we did to make our game work in mobile VR after being initially developed as a tablet game were we had a significantly reduced input options. We simplified our interactions. We made our puzzles better and made them logical puzzles rather than mechanical puzzles, and the game got better as a result. Mobile VR has no wires, and we embrace that. So 360-degree simplified movement system that required higher environment complexity, and it also made us double down on this recursive unlocking map design. This is not necessarily what you would do in every game, but this is what we did for ours, and I think it worked out. Stereoscopic rendering is difficult, particularly with UI, particularly for text. We've worked a lot on text and had to make story changes. And performance is absolute requirement, baseline requirement for comfort that you can't get around. So my Twitter handle is _Pruett. The game is deadsecret.com, and I think I have 1 minute left in my allotted time, which is not enough time to take questions. But fortunately, there's a wrap-up room in 2002, I believe, right across the hall. Also, please very much appreciate feedback that you leave on the little email that you're going to get in about 5 seconds saying thanks for coming to this talk, because we really appreciate it. Thank you very much for coming today.